your BA2 plus, you will get the answer equal to error 7. Okay, so your BA2 plus cannot give you the exact answer for this one. So please go back to try and error. Okay, please try to put in different rate. Okay. Put in different rate and then compute NPV and see that when you just use the concept of try and error, will you be able to get the certain discount rate and get NPV exactly equal to 0? So try a few ways. I don't think any one of you be able to find that. Let me show you this. This is another financial calculator, but it's from Hewlett-Packard. Yeah. So let me try it. 200,000. This is flow 0 or cash flow year 0. Put it there. Cash flow next year 600,000. So 600,000. Flow number 2. This is cash flow in year 2. 500,000, right? Negative. Okay. So for this one, when I asked Hewlett-Packard financial calculator to calculate it, so I need to press IR here. What I want you to see first is that your BA2 plus also use the concept of try and error to calculate the answer. It's actually not so easy. So you just see that on the first row, okay, the calculator tried to put different rates and to see that the answer for that particular rate get NPV on the second row equal to 0 or not. Okay, so this is what I need to give time for my calculator to calculate that. Okay, change rate a lot to see whether the second row equal to 0 or not. If the second row equal to the 0, okay, the calculator will stop and present the answer above. Okay. Now, this is what we need to wait. Okay. While we wait for my calculator to give us the answer, I would like you to see two things. Okay. First one, our calculator or my calculator, okay, try the rates above here. Sometimes you will see the negative sign. See that, right? Okay. So the calculator will also try the discount rate on the left-hand side quadrant. Okay. Those are negative as well to see whether we have NPV equal to 0 or not. Second point from this is that no matter what rate it used for this equation, okay, you can notice the second row that my NPV always be negative. See that, right? Okay. So in fact, I can leave my calculator like this and keep it calculating. Okay. And I don't think it will find any answer. But there are lots of possibilities. Okay. This kind of equation, let me stop it. Okay. And we have no IRR. This is the second case, apart from the first case that when we have the sign change more than once, right? Minus, plus, minus. So when we have the sign change more than once, it does not necessarily to means that we are going to get what? No, multiple IRR case. There are two different cases. First one may be multiple IRRs, or the second case, it will be no IRR case. And for no IRR, what does it mean on NPV profile? Okay, NPV profile that we draw, it will never cut x-axis since we do not have the cutoff point or IRR. There are two ways to draw this graph, or there are two possibilities. Okay. The graph that never cut x-axis may be above x-axis or below x-axis. Okay. In this case, remember, right? I just showed you that for whatever discount rate or required return that we use, all of our answers turn to be negative. So this is what we have. NPV profile of this graph must be below x-axis like this. And again, this is another proof that our NPV profile is actually not a straight line. We just draw a certain part of the whole curve. Okay, this is what we have. So, two cautions for IRR at this moment. First one, beware multiple IRR case. And second one, beware about no IRR case. Any question for this one?
Can you explain it again, like why the graph is below the x-axis?
Because when, remember my calculator, right? That I asked it to calculate IRR.
Yeah.
So you may notice that whatever rate that they try to use on the first row, the second row, see that, right? All the answers turn to be negative. So in other words, whatever required return that you use, your answers always be negative. So it means that for whatever rate that you use, right, your answer still be what? Negative or low x-axis. So that's why I know that my NPV profile must be below x-axis. The opposite way also true. If the calculator calculates something like this, and the answer on the second row turn to be all positive, so the graph will not be below x-axis. It must be above x-axis. For you to know this one, okay, you just try some rate. For example, you may try 10%, 100%, 100%, and you will see that your answers will be negative all the time. Okay, so you know that the graph is below x-axis like this.
Thank you.
Welcome. Okay, right? For this one, second case. Okay, then please look at the next example. Okay. I provide you two projects, L and B. Now, for this one, okay, what I want you to compute is not to draw NPV profile. Okay. But for these two projects, actually cash flows are the same, okay, except the signs are different. For project L and project B, I would like you to calculate NPV and calculate IRR. And for these two projects, nothing indicates that they are mutually exclusive. So let's assume that they are independent projects, okay? So please calculate NPV at 10% and IRR. This is what I need at this moment. And after that, just use each criteria. Okay? Look at IRR. From these two projects, which project we are going to accept, one or two of them or none of them. Okay, also at NPV. Okay, try that first. Calculate NPV and IRR. So you get the same answers, right? Yeah. For NPV 1059.3539 for both of them, except that for project B, the sign is negative. For L, positive. Okay. For IRR, both of them give us the same answer, 20.1289%. For this one, after we calculate NPV and IRR again, right, we need to choose which investment criteria we are going to judge the project. Okay. This criteria. Okay. For IRR, okay, the rule for IRR is that we are going to compare IRR with the required return, which equal to 10%, greater than or equal to 10% or not. Okay. And you can see that IRR for both projects greater than 10% for both of them. So according to IRR, the conclusion is that you may accept both of them like this. Okay. Somehow, you can see the difference in the answer for these two investment criteria, right? NPV say that project L only, okay, but IR say that we should accept both projects. Now, remember, okay, for all investment criteria that we talk about, okay, the best investment criteria is NPV. So, if for project B, NPV say no, IRR say yes, the best answer for project B is based on NPV. So we must not accept project B. This is the best answer for this one, except project L only. Okay. Now, why? IRR give us, okay, incorrect decision for project B. This is what I am going to explain next. Okay. The reason why project B is incorrectly accepted by IRR criteria because, okay, remember IRR, what is it? IRR is internal rate of return. Internal rate of return, it is the return inside or internal or inside this project B, right? Okay, we talk about return, okay, return. What does it mean by return? Return must come from investment. We can get the return only we invest first, like invest, and then we are going to get the return or cash inflows back like this. This is investment project for project L. It is correct. So we can use the concept for IRR for this one. It's okay. But for project B, it is not investment project because we receive cash first. After that, we pay cash out. Okay, this is not investment project. And what this type of project we are dealing with, this is what we call borrowing project. Okay, we get 5,000 today, so we borrow 5,000 today, and we require to pay back 1,500 1 year from now, 2,500 2 years from now, and 3,500 3 years from now. So the rate that we get, 20.13 here, it is not return, but it is cost or interest rate. Since 20.13% is interest rate or the cost, we cannot say that this is IRR by definition or the return, but it is interest rate being charged to us or cost that the firm require to pay. So it will violate all the definition of IRR. Since IRR we define as the return from the project, but not interest rate from the project. So the rule that say we are going to accept when IRR is greater than or equal to the required return. This one will be applied for investment project only, not the borrowing project like that. Okay, so when you see the borrowing project receive cash first and then pay cash later like this, IRR cannot be used because it will violate the rules that we have. So at this point, you see that, right? We have 3 cautions for IRR. First one, beware of multiple IRR case. Second one, no IRR case. And last one, beware about borrowing project. Caution number 4, I will tell you next. Okay, any question at this moment? Okay, right? Now, before I will explain what does it mean by the next investment criteria on page 18, which is what we call codified internal rate of return. Let me this one first. Yeah. Since last time, we say that when we talk about the project, cash flow from the project when we say IRR equal to certain percent, like let's say 40%, like this, cash flows, interim cash flows, or the cash flow before the project ended, we need to reinvest and get the return equal to IRR as well, or equal to 40% in this case, if this is the project that we have. Okay. Now, think about the actual situation. You may come up with a project like this, and this is a very good project. So when you have this very good project, you have a very high return, 40%. This can be the case after you calculate IRR. Okay. But the reinvestment assumption that after we get the cash flows and we need to reinvest at the same IRR 40%. Okay. In reality, it is quite difficult for us to reinvest at 40%. Think about it. When you would like to reinvest, right? The one that comes to your mind is what? Deposit the money to the bank. Okay. When you deposit the money to the bank, the most that you get now today is like 3% or 2% like that. It is not up to 40% per year. This is quite too high. Okay. Or if you can reinvest equal to 40% per year like this, I don't think that you can sustain it, or you will get 40% all the time like this. Okay. So this is not correct. Assumption here is not correct. Okay. Now, what does it mean? When we know we violate, right? Reinvestment assumption here. When we violate reinvestment assumption like this, what will follow? Okay. When we state that IRR, or we claim that our project IRR equal to 40%, we actually get not equal to 40%. We will get less than 40% because our reinvestment assumption is not correct. Now, this concept just leads us to investment criteria called MIRR. Now, what does it mean by MIRR? One thing that differs from IRR to MIRR, okay, is that MIRR, we are going to change reinvestment assumption or reinvestment rate assumption to be exact to equal to I% or required return. Okay, which this one, okay, opposite of IRR. Okay. When we talk about IRR, what we have here is that when we reinvest, right, IRR, reinvestment will be equal to IRR %. But this one, it is not. For MIRR, we are going to reinvest at required return instead. Okay. And how can we change that? We just use the same methods that we proved IRR last time. Okay. So let me put project Q up again. Project Q minus 2000, right? 900, 800, 700, 600, and 500 like this. Okay. So for project Q, okay, when we would like to reinvest, okay, and in this case, we are going to reinvest at required return, in our case, 20% rather than IRR, which equal to 25% earlier. Okay. So when we reinvest at 20%, this is what we have. Okay. Again, one by one. 900 multiplied by 1.2 to the power 4. 800, 1.2, compounded for 3 years. 700, compounded for 2 years. And 600, compounded 1 year. Like this. After that, we just simply sum them up. And we are going to get total future value equal to 5,476.64, like this. Now, after you have that, okay, we just look at this project, just be like this. It's somewhat like we invest 2,000 today, okay? And for 5 years, we do not get any cash flows except very large cash flow, one amount at the end, 5,476.64. Okay. And we calculate IR again for this one. So NPV equal to minus 2000, right? Plus 5476.64 divided by 1 plus IRR to the power of 5 equal to 0 like this. Okay, and this is new IRR, so we called it MIRR. And for this one, MIRR, we can solve this one actually manually. Okay, so equal to 5476.64, okay, divided by 2000. Take square root of 5 minus 1. So we get the answer for this one. And get that? This is new IRR. So we called it MIRR. This is MIRR for project Q. Any question how to compute MIRR here? Okay, please calculate MIRR for this one for project Q and also calculate MIRR for project S as well. Get these two answers, right? Can you get that? Any question for calculating MIRR here?
can we use the calculator to calculate it?
For MIRR, for regular model for BA2 plus, you cannot calculate from that. Okay. But for professional model, okay, I can put the cash flow in like this, minus 2000, right? So for those of you who have the professional model, you can calculate it immediately like this. So I put all the cash flows inside. And after you calculate IRR, okay, remember IRR 23% something for project S, right? Okay. For professional model, when you press arrow down, you are going to get RI. RI is reinvestment rate, or the rate that you want to compute future value equal to 20% like this, right? 20. Okay. And arrow down further, you are going to get 20.0578%. So you are going to get the answer for MIR from BA2 plus professional model immediately. But for the regular model, what you need to do is like this. For project S, you just look at cash inflows only. Okay. 400, 600, 800, 1,000, and 1,200, right? Okay, just ignore negative 2,000, just only positive cash inflows. Okay, now you have the function to compute NPV, right? Okay, so you compute NPV first at 20%, but this is not what we want. Okay, so the first step you compute NPV at 20%. Second step, okay, you just put your NPV here equal to the present value and use time value of money function. Okay, put this one equal to present value, right? Okay, put n equal to 5. Okay, put what? Put I, okay, or IY equal to what? 20%. And then you compute future value. So you just throw your NPV back to be here as future value. Now, you have future value on. After you have this process, you go on to the third step. Okay. You have future value, right? Here, here, same thing. Okay. Now, you just bring back, okay, your initial investment, which equal to 2,000. Okay. And put your 2,000 as present value, right? Okay. Your future value, this is what you have, okay? The future value for cash inflow that you have earlier. You put n equal to 5. And finally, you just simply calculate IY. This is your MIRR. Okay, when you use the regular model, this is how you use it. Is it okay? And for your information, for those of you who use professional model, when you calculate NPV, okay, when you arrow down, you are going to see PB or payback period. It also provides you the answer for payback period. And when you answer down further, you can calculate discounted payback period, abbreviated as DPB, okay, discounted payback period. So for the professional model, it will give you the answer for 5 of them at once: payback period, discounted payback period, NPV, IR, and MIRR. But for regular model, you are going to have only NPV and IR. Right? Any other question for calculating MIRR here? For MIRR, okay. The concept of MIR, it just be the very same thing or similar thing with IRR, except that okay, we just modify for MIRR, the decision rule. We would like to accept very same thing with IRR. So MIR must be greater than or equal to our required return. And we are going to reject when our IRR is less than our required return. And similar thing with, MIR. Similar thing with IRR, okay. Not only required return, later on, you are going to know that the required return is equivalent to what we call cost of capital. So please put cost of capital side by side. Our conclusion for project Q and S based on MIRR is that MIRR must be greater than or equal to 20% first. Okay, this is our step number 1. Remember, right? And for step number 2, okay, since both of them pass, okay, so we go on with independent projects environment or mutually exclusive projects environment. For independent projects environment, we are going to accept both of them since they are not related and both of them pass from the first step, we accepted. The exclusive environment, you are going to accept only one. Between 22.32% versus 22.06% only, we are going to accept the one that gives us the return per year greater than the other one. This is the answer for our decision here. Is it okay? For mutually exclusive and independent project for MIR here. Okay, now one further details for this one. When you just facing the project that the cash flow is non-normal cash flows. Okay, what does it mean by non-normal cash flow again? We have cash flow that change sign more than once, right? Okay. So let me put it this way. We have cash outflow at time 0. Okay? And we also get the negative cash flow or cash outflow in year 2. Okay, the rest are positive cash flows. Okay. After you have this, okay, the rules for MIR is that you are going to compute again the future value, but for only cash inflows. Okay, so only cash inflows will be reinvest. Okay, equal to I% like this. But for cash outflows, you must put them together, okay, to be the relation of the present value of cash outflows. Okay, so for cash flow in year 2 here, you need to discount it back to present value. In this case, I%. If the question say nothing else, okay, just use the same rate. Compute PV here, compute FV here. So the future value will be what? Everything that positive, okay, cash flow that's all positive to be future value. Cash flow, all the cash flows that they are negative come back to be present value. And after that, you just compute MIRR out of that. So let me put it this way first. Okay. Calculate MIRR. Or your MIRR equal to these two, okay, divided by each other and then take the square root. Divided by outflows, right? It's okay. This is for rule for MIRR. And beware, okay? Please take a note that this is the rule for MIRR, but not the rule for PI, the next investment criteria that I am going to discuss with you later. Right? Let me repeat. The rule for MIRR is that all cash inflows must be calculated as future value, or all of interim cash coming in must be reinvested at I%. But all cash outflows, okay, no matter how many times you have at year 0, year 2, year 3, whatever, when of them they are negative, just discount them back and put them together, sum them up as the present value at time 0. After that, you have just two amounts, right? Outflow and inflow. Equate them to find out the rate. That rate is your MIRR. This is how we calculate it for MIRR. Any question for this concept before I just ask you to try to calculate MIRR this way? Now, okay, please turn to page 21 first. Page 21. For page 21, I would like you to compute MIRR for project S. For project S. Let me put the timeline on, okay? So calculate MIRR for project S and read. Like that. Can you get that? Finally, rejected. Any question for this one?
Can you explain again how to compute the MIRR, like from the NPV, like from the last step? When we know, yes, how to compute from the calculator.
From the equation or from the calculator?
From the calculator.
So can you calculate 1,800 here and 2,600 here? Can you get these marks?
Yes.
Right? Okay. So from these two, you may think about it like this. Let me rewrite one more step. Let me move it up. In fact, let me put it in this term. So from it is what? We put negative cash flows together, right, as present value. So our timeline, after you put this and this together and get this one, so you get minus 1,897.7414, right? Okay. And then what we try to do next, okay, we put all the positive cash flows there to be future value, right? So all of them, they are actually gone. We have total future value here, 2,611.7546 like this. Okay. So after you have that, okay, you just think about this one as present value, this one as future value 5. Okay. And if you are given the case like this, what is your rate here? This is your MIRR. Okay. That's why I just simply put them in this equation. Okay. Present value, future value, right? So this equation is what? Minus present value plus future value 5 divided by 1 plus I to power 5 equal to 0. Okay, I just move present value to be the other side. Okay, and from this one, this is the rate called MIRR. Okay, so as I put it earlier, minus 1,997.7414 here, and future value 2,611.7546. Okay, and after you have that, go back to this concept here. This is present value, this is future value, and n equal 5. Right? So minus 1,897.7414. This is your present value. Your future value 2,611.7546. Okay. N equal to 5. Compute what? I, Y. This is your MIR.
Thank you very much.
Okay. Okay. In fact, You can practice for MIR for other 4 projects later on. Okay, but I would like you to grasp the concept here that when you have non-normal cash flows, the rule for MIR is that all cash outflows must be present value. All cash inflows must be future value at the end of the project life. Okay, 10 years, so this one will be future 10, FV10. Okay, and you are going to have only 2 amounts, present value, one future value, then so what is MIR and IRR? Okay, I can say like this, that okay, IRR is what? IRR is rate of return of the project, which assume what? Assume that interim, right? Interim cash flows are reinvested at IRR percent. This is for IRR. Okay. Now, if you change this one to MIRR, okay, MIRR, same thing, is rate of return of the project, which assumes interim cash flows are reinvested at required return. This is the main difference between the two. Okay. Any other things are the same except this one. Okay. And beware, for MIRR, okay, you must know that for MIRR, all cash outflows, okay, must be computed as present value together, okay? And all cash inflows, okay, must be computed as future value at the end of the project life. This is for MIR. And then equate PV and FV. Okay, any question before we take a break at this moment?